One of the most difficult aspects of three-body to conceptualize involves exactly what the trisolarans do to the aforementioned proton before they shoot it off into space. They unfold its multiple dimensions into a massive planet-sized amount of space, inscribe a giant supercomputer onto its planes, and then refold it back into its original microscopic size. This is a difficult feat to imagine, much less conceive in reality. Yet this practice exists, at least in theory, as an idea of multidimensional unfolding. Imagine this the way you might imagine creating a simple paper fortune teller. The paper shape starts out almost fully flat on a single plane, but it can be uncompressed to reveal more and more layers until you have a neat schoolyard divination tool. Now imagine this happening on a grand scale, and with even more dimensions than the three we experience here on Earth. Unfolding dimensions is not a standard term in physics or mathematics. However, we can interpret the phrase in a speculative sense based on existing concepts. In general, dimensions refer to the independent parameters required to describe the position and movement of objects in space. For example, in everyday experience, we often think in terms of three spatial dimensions, length, width, and height, and one temporal dimension, time. The term unfolding dimensions could be understood as a concept related to the expansion or revelation of additional dimensions beyond the familiar three spatial dimensions and one temporal dimension. This idea is reminiscent of certain theories in theoretical physics that propose the existence of extra dimensions beyond the ones we directly perceive. For instance, string theory suggests the existence of additional spatial dimensions beyond the three we experience that are compactified or curled up at incredibly small scales. These extra dimensions play a role in the behavior of fundamental particles and the forces of nature according to string theory. Similarly, some cosmological models propose the existence of extra dimensions beyond the observable universe, often in the context of theories like brane cosmology or higher dimensional space-time geometries. It's important to note that these ideas are part of speculative and highly complex areas of physics. They are not yet experimentally verified and remain theoretical constructs that scientists are actively exploring to understand the fundamental nature of the universe.